Okay, let's get started. Today I don't have any slides prepared. Today I just want to, since there's still quite a bit of questions about using the command line and using Git and everything, I want to go through this new kind of centralized guide to pretty much all the command line you're going to need. I've updated it so that it has information for, I think, however you have your setup, whether you're using Vagrant or Windows Substance or Linux, or you just have a Linux machine. So I've tried to make it universally applicable. And then I also want to go over just like kind of fundamentals of recursion, at least kind of the way I see it, and show how we can do the code generation, that set of recursive functions for code generation. We went over it last time how it works, but today we can sort of collectively write these recursive functions in pseudocode. So perhaps that'll be helpful. And if we go over some ideas about how we do recursive algorithms, hopefully that will help. Okay, so the first thing is going over the command line. So I realize that people are at different stages of their kind of computing nerdiness and their ability to use the command line. Maybe you've been using computers since you were 5, or maybe you're just new to it a year or two ago in the computer science program. But I strongly believe in the command line for whatever you do in computing. If you can use the command line, then you can use the graphical user interface. But the converse is not usually true. If you can use the graphical interface, it may be harder to do some of the more low-level or advanced things with your machine. So for some of you, this might be review or this might be boring, but hopefully I can give at least some tips on using the command line. And also I'll show you how to run the grading scripts again. So they've been updated. There were a few bugs that were found that I've corrected. But so I just want to walk you through using the command line, some command line foo. But before I start, any questions? Questions on your setup, questions on the project description, homework? Yeah.
Roughly, when do you do like the next check in case people turn in?
Regrading.
Yeah.
I asked the graders to do it this weekend. That's good. I asked the graders to do it this weekend. But with the little tutorial I'll do today, you should be able to just grade it yourself and see pretty much exactly what the grader will see. Yeah.
Since we have like two more weeks to submit the assignment, like if you submit it on Tuesday, like
yeah,
and you regrade on the weekend, what happens to other people who submit on Monday and Tuesday? So my question is, they're gonna regrade on the weekend and release the grades, but what about people who submit on Tuesday? When are those gonna get graded?
They'll be regraded eventually.
Okay.
Yeah, eventually they'll be regraded. But hopefully after today, you'll just be able to like get pretty much exactly what your grade is, more or less. You'll be able to like grade the project yourself. I'll see. Well, yeah, I try to have the graders do it every week. Maybe we can do it more often. Yeah. Okay. What other questions do you have? Any other questions? Yeah.
So as far as like the location of where we need to make the main file,
yeah.
Anything great? Do I have to clone the repository inside the Vagrant virtual box?
So I'll go over that. I'll go over that today. I have like kind of a standardized way that you can set it up, and you can go through this guide. I recommend you go through this guide, and for the steps you've already done, just ignore that. And I'll show you how to like check to make sure your setup is the way it should be in order to use sort of cut and paste the command line commands I'm giving you. All right, so I'm assuming that you either have the Vagrant set up, in which case that /Vagrant directory has got to be mapped to your host machine, and I'll show what that looks like in a second. Or you're using your own virtual machine, or you have Linux natively installed, or you have Windows Substance for Linux with Ubuntu 18. So I'll show kind of both ways. I'm assuming that whoever, like you've all got your virtual machine set up, or you're all set up with Linux, so I won't go over that. For those of you who didn't use Vagrant, you'll have to have these packages installed, and this is the command you can run. I think for most of you, you've already done this. Otherwise, you wouldn't be able to compile your project. For those of you who have submitted to Git already, you probably got this complaint from Git that you didn't set up your username and email. So this is how you do that. This step here for setting nano as your editor, this is important for those who didn't use the Vagrant machine and got Vim, this kind of esoteric text editor. Whenever you type git commit, it just by default uses this old school text editor, which has pretty esoteric commands. It's not self-evident how you use it. So running these commands will configure Git to use this simpler text editor for entering your Git messages. Okay, and so for setting up your repository. So assuming that you've done homework 1 and actually set up your GitHub repository for GitHub Classrooms, to clone it, either go to this /vagrant directory, and that's because that is accessible on your Windows or your Mac host machine under wherever you put that syllabus. If you still haven't set that up yet, then let me know. Let me know in office hours or ask on Piazza. But if you have your project in this directory, then you're going to be able to edit the files in your host system. Otherwise, if you're using your own setup, then I recommend just using your home folder. At least that's the way all the paths are going to be set up in my examples in the home folder. And of course, to clone your project, this is the command you should run. If you're editing source files and you're not in a directory called project-your user ID, then it's going to be very hard to actually upload those to GitHub. So if your source code should be in a directory called project-user ID. And that will be created when you run this command. So just to illustrate this very well, okay, does anybody have questions on this? Does anybody need me to show them doing this command? Yeah, you want to see it?
So I guess,
Yeah.
my question is, are we running that when we have Vagrant up and running, or we're already up and running?
Yeah, yes, yeah. So you SSH, you should do Vagrant SSH to be get into your machine, your virtual machine. And all of this is in your Linux machine. However it's set up, all of these commands assume you're running in the Linux machine.
So Vagrant SSH, navigate over to the Vagrant folder?
Yep, change directory to Vagrant, and then do this git clone. So I've already got, well, let me move my existing version. So that command, most of these commands now, I think you can pretty much cut and paste them, which should make it pretty simple. Oops. I'm not going to show this because I don't have my SSH key set up. But hopefully everybody can do that. You can do git clone and put in your username and password, and then you'll get your directory that you can. CD stands for change directory. That's how you can enter this directory. And now I'm inside of my project folder. So I'll go over some more of the git commands later. But as a good little tip, if you're lost inside of the command line, rather than running to the graphical file explorer and trying to click through this kind of heavyweight graphical interface, you can just type pwd. That means print working directory. That tells you where you are in your file system. So hopefully all of you understand this file system is like a hierarchical set of directories and files. Assuming you know that, if you say pwd, it's going to tell you where you are in the file system, starting with /. So for Windows users who may be used to C: or D:, in Linux, there's only one top-level file system, and that's /. And everything is under that file system, including other drives. If you have multiple drives or a CD-ROM, if those still exist, they're all going to be under this root directory. So this is where we are in our file system, which is exactly what we expect. We want to be under the Vagrant directory, under root /, which is the /, under Vagrant, and under project test, which is our GitHub repository directory. And if you want to see what's in the directory, type ls, which is short for list. And that'll tell you where you are and what's going on in that directory. And so you can use change directory to move around. So ... means go to the parent. So you can see now I'm in /vagrant instead of /test, /vagrant/project test. I'm in /vagrant now. And I can sort of string these relative paths together. So where am I going to go if I change directory to ... /vagrant? Where am I going to go at this point?
Just gonna go back to the same
Yeah, you're going to stay in the same directory. So I'm going to go to the parent, and then I'm going to go to the subfolder called Vagrant, which is the same folder that I'm in. Okay, so that's, and what if I change directory to dot? Where do I go? So dot is your current directory. So I'm just going to stay in my current directory. So these are like two special relative directories that are in every directory. Dot just means current directory. Dot dot means parent directory. Okay, so to find out where we are, I can just type pwd and ls. So I type that, probably like hundreds or thousands of times a day when I'm programming. Another tip, if you don't know this yet, is instead of typing painstakingly typing everything out, hit the tab key. And if I have two directories that have a similar name and I try to change directory and I keep hitting tab, it's going to tell me, it's going to use the prefix that I've written and give me all the possible options I have. And if I keep typing, then it'll finally, if I hit tab, it'll finally complete it for me. It's called auto completion. It's also something I probably use thousands of times a day. And this makes navigating your computer, your file system using the command line really, really easy. And in some cases faster than using the graphical interface. Okay, so that's just basic questions on that. I think that's probably review for a lot of you. Okay, so this is kind of a new step that I think everybody should do, even those who have Vagrant set up. If I type just CD by itself, where do I go if I just type CD by itself? Is any Linux users here? I go to my home directory. So by convention, it's /home/ the name of your user. In this case, my username is Vagrant in my virtual machine. So I'm recommending that everyone clone their syllabus in the home directory of whatever machine they're using. And so this will solve a bunch of problems. It'll make all the command lines uniform for everybody. And it'll also get rid of the whole Windows file ending problem, which has been causing tons and tons of headaches for me and other students. You can just Google that on Stack Overflow and see how annoying that situation is. So by having the syllabus cloned in the virtual machine, it'll standardize what the command line instructions are. It'll get rid of the line ending issue, and it'll also make sure that you have an easy way to get updates to the syllabus. So if there's some new tests that I release for Project 2, Project 3, then you can just enter this directory. So change directory to syllabus and just say git pull. And if there's anything new on GitHub, then I can just get those new changes and they're right in my virtual machine. Does anybody know what this tilde means? So this is actually, this little is not a dash. So this thing is not a dash, not a dash. Does anybody know what tilde means in the Unix world? Nobody? Oh yeah, okay.
Isn't it like your user folder?
Yeah, it's your home folder. It's your home directory. So if I change directory to tilde, then I'm in my home directory. So for people who are comfortable with Unix, that's like a familiar thing. You can even go to other users like root. So I can say tilde, the name of the user. Of course, it won't let me in there because I don't have permission. So if I change directory to tilde username /, that's my home directory. Is this review for some of you? Review? No? This is new? Okay. Okay, so that's what that tilde means. We know dot dot, we know dot, we know tilde. All right, so now we should have our syllabus inside of home. We don't need Bob. So if I type ls, I change directory to my home directory in any of these many equivalent ways. So all of these are the same way to go to home. And I type ls, now I see that I've got the syllabus, the git syllabus in there. Okay, so the next thing that I'd like you to clone is the grading scripts. So again, change directory to your home directory and just copy this instruction here to clone the grading scripts. If I go into this directory, I'll see that it gives me a bunch of Python and shell scripts, and I'll go over how to actually use those in a second. All right, with me so far? Any questions on this? Hopefully some of you are following along. It looks like people have laptops out. I'm assuming you're not reading, doing other work or something. Okay. So there's just instructions here to show how you can update both of these repositories. If there's bug fixes with the grader scripts, or there's new test cases or new fixes in the syllabus, you can just enter those directories. Now we know that this tilde means the home directory. So we can just enter those directories and say git pull, and that'll give us any updates that we the instructional staff make. Okay, so for those who are using Vagrant, you should have these three things. You should have this vagrant/your project directory, and you should have two directories in the home directory. So I'm at home, and I have two directories there. If you follow the directions for those who aren't using Vagrant, your project, the only difference is your project directory will also be here at home. So for those people, they have a way to edit their files within their virtual machine, or they're using Linux natively. For those who are using Windows or Mac, you probably want to keep it in the Vagrant directory so you can edit on your host machine. Questions on this so far? Questions on this? So this will give you, so now you have, change directory in ls. So this gives you a way to actually verify that your setup is what it should be by just comparing to these directories. Okay, so makefile. So I think some people still have not set up the makefile yet. So now that your system is set up in this way, in this consistent way, we can, the way you get the makefile is you just copy it from the makefile I give you into your own project directory. So to go into your own project directory, you just do change directory wherever your project source code is. And then you simply copy using CP, which stands for copy the makefile from this path into /. So again, what is //? What path is that? It's your current directory, yeah. So I changed directory to my project source, and now I'm copying some other file somewhere, which I've given you, into my current directory. And when I do that with this little magic here, I can see that my makefile was copied. Well, it's 3 hours later because this machine is not on Eastern time. But you can see this makefile its timestamp is like now. It was just copied in. Okay, so a little bit about Git. So some students ask, like, well, how do I tag a specific file? So in Git is Git doesn't track individual files. I mean, it does track individual files, but the point of Git and other version control systems is to track changes in the source code. So when you add a file or you edit a file and you commit it, so if I do this commit of a makefile, whoops, it wasn't actually added yet. So if I add the file and then commit it, just like, and I didn't set up my, I didn't set up my stuff either. Okay, well, I'll show you how to do this as well. So I'll set up my user. I'll just use the example. Okay, so I added my file, and I go to commit it. You just give, so added a makefile to my repo. So once I do that commit, it's not that Git is tracking this file only. If I tag at this point, so you can see here, before I added the makefile, I tagged my project. I already tagged my project to be project 0, which is why if we were to look at this project on GitHub, and actually I haven't pushed it at all. Well, anyway, I'll push it later and show you what that looks like. But I tagged my repository before adding the makefile. And so we don't tag the makefile, we just tag the latest commit that we made. So if we made changes to the source code since tagging it, that tag will not have any of those changes. It's just a history of source code changes for your entire repository. It's a history of changes rather than a list of files. So, if you go become a professional software engineer, version control is industry standard at this point. That's a good thing to get used to, this concept. So I can even look at the differences between, I can say, what's the difference between when I tagged when I tagged my repository. So I said git diff proj 0. So proj 0 is what I tagged before adding the make file. And if I ask Git, I can ask Git to tell me the difference between my current version and the version that I tagged before. And so I don't tag the make file, I just tag the version of source code that I'm currently on. So I just say git tag, but project 0 already exists. So how do we update this tag? We can force, so Git is just not letting you reversion so easily, because you could easily make, the version is supposed to like never change. If I release version 1 of my software, I shouldn't be changing that. Instead, I release a new version of my software. This is like basic software engineering. But I can force Git to do this, to do what I want, and make Git tag a new commit. And so now the tag was originally here at this earlier commit, but now the tag is on my latest commit after I added my make file. Questions on this? Questions on Git and Git version history? I feel like I've explained this several times, but yeah.
So if you added your C file or your make file as well, it's like you added it before you commit it, you tag it.
Then yeah, it won't appear under that tag. You have to commit it. You have to commit it. So the commit is what makes records a change to the source code. So adding the file, yeah. So Git is not like a file system. It's just a list of changes to source code. It just so happens that if you want to have it record the fact that there's a new file, you say git add, but that is not actually recorded into the log until you commit, until you do a commit. So that's why when we had this diff, although this diff is going to be different now, but so this diff shows the entire source code of my make file. When I diffed it to the old version, it just recorded it as a bunch of changes from an empty make file to the complete make file. So it's just changes in your source code repository rather than individual files. Yeah.
It shows them side by side if you actually had something in that first make file, right?
It won't show them side by side, but it will show them. It'll show like there'll be minus signs here for what was deleted. But there are all sorts of tools you can use for looking at differences. And if you become a professional software engineer, you'll probably be using these tools. To do version control is, it's day rigor these days. Yeah.
So as far as the make file goes, saw that you were copying it, but
Yeah.
Is there one already created for us that's just in the project?
No. The project folder is like empty except for a README with nothing in it. So I gave you just completely blank slate to work with.
So as far as creating a make file,
You just copy it. You just copy the make file. So this is the syllabus, which you have hopefully cloned in your home directory at this point. And you just copy the one I gave you, and that will just work for most people. Yeah, that one will work.
you don't have to get up or
No, it does all the compiling and linking for you. As long as it should be in the root of your repository, because that's how we grade. It just by default will take all .c files in the root of your repository, compiles them and links them into
you gave us a make file that is going to be in the syllabus directory. That's going to be, if you clone the syllabus directory of root, you should start with it.
Exactly. Yeah. It'll just be there, and you just copy it into your repository. Okay. So maybe okay. Okay. Let's see what else we got. All right. So that's adding and committing. This is adding and committing your source code. So it's the same idea. Once you make that source file, you have to tell Git that it exists. You only have to do that once, and then from then on, whenever you make changes to the source code, you commit. For instance, at this point, so I've got, let's see. So this is what my README looks like. Cat is just a command to print out whatever file or input is given to it. So if I edit this file, and these are my new edits. So I can actually ask Git to tell me the differences between my working directory and the committed changes. So I haven't yet committed this README file yet. If I say git status, Git will kindly tell me every file that it knows about that's been changed, and every file that it doesn't know about. So it doesn't know about any of these files, for instance, Simple C. So I can add this as well with that. Oops, I spelled it wrong. If I say git status, now it knows that there's a new file, and it knows that there are some files that have been modified. So in order to record these changes in the log, I say git commit and the name of the file. So I've updated the README. Oops. I've updated the README. So if I look at my log, now you can see my tag is on my last version when I added the make file to the repository. And my new commit is this, I've updated the README commit. So this project 0, it's like foregone conclusion. It's in the past. It's in some history of your code changes. And this makes sense for software engineers, right? Like you modify code and you release new versions of it all the time, and you would just want to name what those versions are. But you also want to record the history of your project. So in case there are bugs or there are changes you want to integrate, then you know exactly all about them. Yeah.
So what if you add file to the directory that you want to announce?
How do you remove a file? Okay, let's see. So let's touch some buggy piece of code. And if I edit this, so this didn't work for some reason. Okay, so I add the file using add, and if I type git status, it'll show me here's all the stuff that's new. I commit this new file buggy. Added a new feature. Added new features, yeah. My good English. See, it's buggy. So status, doesn't see it anymore. If I do my git log, I can see there's a new change here. Oh yeah, so how do we remove this file? So let's say I did some other work after it. So I added my source file here. So I've made a bunch of changes even since I added a new features here. I've even made some changes since then. So what if I just want to remove a file? I just use git rm for remove. So I want to remove this buggy file now. And not only is it removed from the, it's staged to be removed, but you can see it actually removes the file from my directory. If I type git status, it tells me that there's a pending deletion that it wants to do. Just like there was an added line, now there's a deleted line. And so just like before, I just say commit. And just in keeping with the bad syntax. And now it's gone. So removing doesn't undo history. It records the fact that it's undone. So you can think of this as an immutable log conceptually an immutable log of changes to your source code repository. So that way, if this is great at work, because if somebody's like, who made this change? Why is this so broken? Then you can say git blame, and it'll give you a nice little list of each line and each commit that caused that line to be in the source code. So you can imagine for programming, which is kind of a delicate task, to get a large project working is no easy feat. And when you're coordinating with lots of people, it's really important to make sure that changes to the software are very carefully controlled. You can imagine if you're, especially if you have life critical applications, you want to make sure that nobody's just arbitrarily cutting and pasting their source files to their home drive and making some changes and then copying it back to some network drive. This will lead to all sorts of problems. Maybe you fixed some bugs a year ago, and then you made a change today, and those bugs reemerge. You want to make sure you have a record of what happened since then to cause those changes that reintroduce these bugs. So anyway, this is probably more for a software engineering course. But yeah, so it's a history of changes. I think I can even still ask about, I'd have to ask for the older version of buggy. So anyway, you can read a Git guide for the more fancy stuff. Okay, other questions on this? Other questions? Yeah.
So once we got our tag done for project 0,
yeah,
and we created, and then we finished project 1,
yeah.
do we create a
a new file for what?
I mean, what do we, I don't
Oh, you can just keep modifying your source code. So you can think of this as like incremental development, where project 0 is like version 1 or version beta version of your compiler, and then you just keep modifying the same files. So you don't have to like create a new project. This is one project where you're adding features to it. So just like in real world software development, when you want to make iOS 13 is not like, they probably didn't write it from scratch. They took iOS 12 code, made a fork of it, and started developing from that code base. So this is the same. I mean, that's the same thing I recommend you do as well. You might have to make like drastic changes, and it may not look like the original source code anymore, but just continue on the same source code. No, you don't have to add new files. Yeah.
And do we
Yeah.
tag it as project 1?
Yeah. You tag it as so there's a tag for each project, so that can be distinguished. Think of them as just version, beta version, alpha version, version 1, version 2 of your software. Any other questions? Yeah.
Should we have a make file for each project?
No, there's only one project. So there's only one source code repository, and it only needs one make file. So
Okay.
in this case, that's why I call my program just simple c.c. You can forget about this O file. That's some leftover detritus. So simple c.c, that's just my compiler. And over the course of the semester, I continue to add new features to it. It's the same. I mean, this is like a philosophical question. Like, when is a piece of software the same piece of software? Is Android 9 still Android if it's different code from Android 8? If 50% of the code is different, 90% of the code is different, is it still Android? But anyway, that's a philosophical question. For this, it's one repository. And so you keep making changes to that same piece of code. But in order to record the fact that there was an older version, we just tag some point in the history. We name that point in the history and say that's some special version in the history of this code. So you don't need any new files. You can just continue to extend your source code. Yeah.
So when you have your project 1 ready to be committed,
Yeah.
you follow the exact same.
Follow the exact same process. So I've made my changes to the Simple C program. So let's say, this is my new features to Simple C. Oops. So I made some new additions to the Simple C program. I can actually do a diff on that file, and it says, okay, well, here's the new stuff that I added. Any new, Git status will tell you that there's some changes that haven't yet been committed. So I commit these changes. Let me do good practice here. I think I finished project 1. Yay. So now I've got, no changes yet left to commit in my repository. And I think this is the one to go. So I just git tag my current version with project 1 now. And you'll see if I do git log, it'll show me the history of all the changes. So my current version is tagged with project 1, but if you go back in history here, go back in time, I still have my old project 0 tag here. It's just on a previous version of the software. If you had just taken all of this set of changes from, whatever time this is, midnight UTC time, all the way back to 2349 today, then if I undid all those changes, I would just get project 0 back. So it's almost like, like accounting, where you don't keep track of the balance, you just keep track of the changes in the balance, all the pluses and minuses in your balance. So you don't even need to store your account balance, right? If you know all the additions and deletions from your account, then you know what you can just compute the account balance. So this is the same idea. Git just stores just the diffs between versions. And if you want a particular version, you just add up all the diffs until that point. Questions on this? Any other questions? Yeah.
And you can see your changes when you go to GitHub and you go to your repository like online.
Yeah, you can go to your you can. There's a little thing that says like history, and you can see it for the syllabus, for instance. You can even do it on individual files. So I can say, what's the history of the syllabus? And it'll give me a list of it'll give me the log of all the commits. And this is a nice little graphical interface. I can browse the version of the entire repository here. So see, it doesn't say master here, it says some commit. I can look at a diff. So if I click on that, it'll show me the changes I made. So I just Apparently changed 6 to 5. Oh, right. Yeah, these were the broken examples. Yeah. Other questions? Questions on this? Yeah.
If I name my project 1 file something different than my project 0 file, how would I still?
You should just remove project 0.
Oh,
Just git remove, because otherwise it's going to try to build both of them and link them, unless you change the make file.
and then I would just I'd commit the make
Yeah.
file with the project 1 file.
No, make file is the same. The make file is the same. You just delete your old source file and add your new one. And so it's not really deleted, right? It's just deleted from that version. You can go back in time, check out project 0, and get the original source code. And you'll see this if you look at like Linux or Android or any of these online software repositories. You can go back in time and see their earlier versions through these tools or tools like them. Other questions? These are good questions. So this is basically like software engineering 101 now, rather than systems. Well, I guess, yeah, system software engineering. Other questions? All right, let me get through the rest of these. Let me get through the rest of these instructions. So there's your repository, getting the syllabus, getting the grading scripts. That's your file system, make file. I think we went through Git enough. Okay, so now that you have this make file here, you can, as hopefully you know by now, you can just run make to build it. And watch lecture 01, which is the second lecture. Just watch that for a description of make. Make is pretty cool, or you may not use make in your life as a professional software engineer, but you'll certainly use a build automation tool, whether it's like Gradle or Ant or any of these other more modern build system tools. Because if you have 12 million lines of code, you don't want to recompile the whole thing every time. You want to compile only the stuff that's changed. So that's running make, and hopefully you all know how to run. So does everyone know how to run their compiler now? Hopefully everyone knows how to run. Who knows how to run the compiler, their own compiler? More or less? Okay. Should I go over it? Anyone want to go over it? Okay. So because you use this make file, the make file will take whatever C files you have, whatever they're named, doesn't matter what they're named, and compile and link all of them. So if you got two main methods, like project 0 and project 1, the compilation is going to fail. Their linking is going to fail because there's two mains. So make sure you have one program, and whatever the C file is named, because of this command here, it will be output as the simple C program. And that is annoying. Okay, so I run it by just like this. I just say /simplec for various reasons. If I just say for kind of annoying bash reasons, if I just say simple C, it's not going to work. I have to say /simple C, and that's because the simple C program is not in the path that the shell looks at in order to find programs. So you have to give it the explicit path to the program, and you can do that by just saying /. But anyway, that's kind of a detail. Okay, so here's an example of running simple C. So notice now that you have your syllabus cloned to your home directory, we can start pointing to the test files in our home directory. So I'll just copy this whole command here. And your program should just print out the LLVM file to standard out. That's like a requirement for grading. Questions on this? Yeah.
If you have separate files, like one that has functions in it, do you have to do a header file with that?
If it's a C file, you mean?
Well, yeah. If you
For
have
your
a C file that your main, and it calls another file that it uses functions from, do you have to do?
So you're asking about the source code for your project?
Yeah.
Yeah, I mean, that's typically the way it's done. It's just,
How do
yeah,
you do a header file?
you just make a file called .h and just say include, #include. So it's literally just cutting and pasting the file into your source file.
Is there anything in your header file that you have to put in there, or can you just leave it blank?
If it's blank, it doesn't do anything. It has no meaning if it's blank. So it has typically the header file has the declarations of functions that are not defined in your own C file. So actually, I think I show this in the lecture 01. So if you watch that, I'll show like using a header
My
file.
questions are
Yeah.
actually based off of that video. So when you have your header file, and because I tried putting some functions in there when I did your video, when I followed your video, and and then I had them in another, because I had a function.c like you did, and then I had a function.h that I didn't put anything in there.
Okay. Let's talk about this offline. As this is, I think it's a little off topic, but I can help you work through that. So, yeah, I can help you work through. But let's take that offline. Yeah.
Why do some of the files have a tilde right next to their name?
The tilde is my editor puts backups of the files.
Is that why?
No, because it's just my editor. I use this editor called Emacs, and whenever you save a file, it backs it up to something called blah 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 tilde.
Yeah, the same thing happens to me as well.
It's just a backup file. You can just like remove all of them if you don't need the backup. But okay, anyway. So to run the output of your program, you do this little extra syntax here, this little caret, which means redirect the output. So when I ran my compiler, it printed out to the console all my source code. But I really want it to be print to a file. So I'm going to print it to this file. It's in the temp directory. So if I say type cat, it'll just print out that file. And then to compile it, so this is compiling the output. So the output itself is a program, and I need to turn it into machine code. So this is where I can just use Clang to do this. So hopefully this is mostly review. So as long as if I don't get any errors, that means I produced valid LLVM, and I can run it by just putting the path to the program. Questions on this? Hopefully everyone's done this by now. I think everybody's done this by now. Okay. Okay. All right, so grader scripts. So the way that you use the grader scripts, assuming that you've already set up your repositories, is like so. You just run the grader script. So it's a Python program. This is the name of the Python program. You give it the path to your repository, and then you give it a path to a directory that has a bunch of test files or simple C files. That's all that is. You can read these directions to see more info about that. Okay, so if I run this, I will, because I did not install this. So this is one of the dependencies that is described in the, oops, sorry about that. Okay, so if I run my grader script, I get a bunch of this output. So first it calls make. If that fails, it'll tell you it fails. And then it goes through each one of the .simple C files it can find in the directory you gave it. It actually spits out the commands that it runs. So if you get an error, you can just rerun the compilation step, the step that runs your compiler, and the step that runs the output program. So these two commands that start with bash, you can actually just cut and paste those and run them on your command line. So if this failed, if trying to compile all that simple C failed, I can just cut and paste this to my command line, and well, more or less. I can just cut and paste that to my command line and run it. And then at the end, it'll tell you, how many test cases passed. So questions on this? Questions on this? Okay, so you can just literally cut and paste this. So this gives you a little description of the output, tells you how to run the individual commands. So if you want to verify that Project Zero is working, like you pushed it right, and it's the version you expect it to be, you can say git checkout Project Zero. So when I do that, it'll roll back time and put me to an older version of the source code. And then, I can run my grader scripts on that. And you can see here, when I try to run the grader scripts, it tells me error, running makefile failed. So maybe you fixed your source code repository and you committed changes, and that worked. But you had some old tag for Project Zero, and when you go to check it out and run it, it fails. So that'll just like a little sanity check to make sure that that tag is, the one the grader is going to see. To get back to the head of your source code repository, you can just say git checkout master. So that's all listed here. All right. So committing the project, I sort of showed that already. Make sure you've done all your commits or submitting the project. You just run git tag to name it, and then git push -- tags. Questions on this? Questions on this at all? What questions do you have? Yeah.
So I think I named my project 0. So you want to name it simple C?
No, it doesn't matter. Whatever C files. Like if I rename, so you can say git move, git mv. So I can. That's basically a rename. So I can rename this to like, gobbledygook. So now my compiler source code is in this strangely named file. Oops. So now I don't have any of my built files. So if I run make, it's just going to take whatever C files you have in the directory and build them and link them into a program called Simple C. So this is like, hopefully you saw this in CS1 where they explained just what the command line arguments of the C compiler are. But -O just tells you, the program. So now I can still run Simple C. No, you can put as many as you want. There's as many C files as you want. But if you want to do linking, you might need header files, and you can watch lecture 01 for that. But you can just do one C file. But you can do as many as you want, as long as they're linkable. Okay, so this is just the website you can check if you want to check your releases online. So I don't think I have any releases yet. But if you go to this URL, then it'll show you all the releases online. And there you can even browse those. You can click on the hash number here, go to Browse Files, and this will allow you to view on GitHub what that looks like on GitHub. So now, even though my local repository has been tagged with Project 0, my remote repository hasn't. So that means if you see that, that means you haven't pushed the tags. You haven't pushed or you haven't pushed the tags. Questions so far? Questions on this? Okay, so resubmitting, we went over this. You just force the tags and force push them. And this is the same deal. You can just check out, this is, if you want to like do a fresh copy of your repository, you can say git clone and then give a new path at the end, and it'll be cloned in a different place. It won't be cloned in the current directory. It'll be cloned wherever you tell it to be cloned. Okay, questions on this? Questions on this command line magic, Git, getting your tooling set up, getting your project set up? Anything at all? So hopefully, even though there's not the whole class here today, this will hopefully put it. Oh, okay. Go ahead. How you what? How you run the test scripts? Just go to the section here that says that has this Python command here under Run the Grader scripts for all test cases, and from your project directory, make sure you change directory into your project directory. Just cut and paste this command, and voila. Good. All right. So hopefully this is like a nail in the coffin of using tooling. So you may still have some issues. Maybe your repository gets into like a broken state. That can be done very easily. I've done it very many times to myself, and it can be quite a knot to untie. Stack Overflow is your friend for these cases, or you can come to office hours. But hopefully, if you just use these commands, this gives you like everything. I think everything you need in order to use the command line for this class. Okay, so enough with command line. Any other last questions? Final questions on this? Yeah.
For that, the repository check at the end, you delete that temp project directory.
No, it'll make it for you.
Okay.
Is it breaking?
I wonder where it went in mine.
It went to /temp/ whatever. Yeah. So if you change directory to that, or just try running it again. So make sure you do this change directory command.
Yeah.
And make sure you copy the whole.
Oh yeah, I did that right.
The whole path.
For some reason, I can't copy like that into my command line. Maybe I'm just going crazy.
Windows has a weird way of doing it, I think. Like right click. Oh, Ubuntu? Then Control Shift V.
Control Shift C.
Okay. Control C to copy from the web, and then Control Shift V.
Thank you.
So anyway.
Thank you.
Yeah, so I'm a huge fan of the keyboard and I mean, you've seen the keyboard in my office. You know, I'm
You're
a
crazy.
big fan of using the command line. And for development, I mean, for many, many development tasks, it's actually way faster. You could be way more productive. And then, you know, your boss will love you and you'll make more money. So I strongly recommend, you know, because this is computing, right? I mean, this is like terminals, like the essence of using a computer. So hopefully, you know, you should have some ability to use it before you escape from UCF. Okay, so let's get into the conceptual topic of this class. So I just wanted to talk today about, so this is kind of a light topic today anyway. I just wanted to kind of do a little, like go into a little deeper into doing recursive algorithms. So I think a lot of students tend to have like trouble with recursion. Recursion is kind of I mean, I did when I was younger. It was kind of a tricky thing to wrap your head around, right? So does anybody feel like confident about recursion, like writing a recursive algorithm? Okay. So does one of you then want to tell me? Let's do factorial. So for one of you who's confident, pick one amongst yourselves. Okay, we have a volunteer. Oh, okay, sorry. We have one volunteer. You can help. So I noticed those who said they understood it, that was like 12 people, and those who were confident was like 2. 3, okay.
I can take a shot.
I was asking someone who's going to like write the factorial method. Can we do factorial? Let's just do it together, or you walk me through it.
Super slow way of factorials.
The super slow way?
The recursive descent for
Is recursion always the slow way for factorial?
No, but for some it's slower than doing it in like say a manner. So
Well, I trust my compiler to optimize for me, so I'm lazy. Okay, so let's just go through the factorial. So the confident guy. So here's here's my name of my method. So walk me through it.
Want me to do like pseudocode?
Yeah, we can do pseudocode.
Okay. So yeah, it'll be a function with an if statement.
It'll be a function with an if statement.
I don't remember exactly how it's done. I remember you would have when you do like factorial 5, you pass in.
Okay, so this is an interesting strategy. So like, let's do an example. So if you have, that's what you're saying, right? Like, oh, I don't really remember. So if I have factorial of 5, how does that work?
So you start at 1 and
You start at 1
you pass in 4, 5.
or 5.
5 would make more sense.
Okay.
You start at 5 and then every callback you pass in 1.
So every callback, somehow there's going to be a call to factorial 4, some kind of recursive call to factorial 3, and so on. So somehow this is going to be multiplied with 4. Well, is that right? I mean,
It's like the return. You have
there's some eager people. Oh, now people are confident, huh? Now people are confident. Okay. All right. One more person. Who's most excited? That guy's using 2 arms. So okay, go ahead. Go ahead. Yeah. Say again? Okay, the incoming parameter is going to be some integer being, so it's going to have some parameter. If the integer is less than 0, then you return x. Uh-oh, you're already getting dissent. Okay, I mean, there's a lot of ways to do it. Okay, so I know, what's that?
No, actually, yeah. That's
So this is funny. This is like the fruit fly of recursion. You know, you always see this and you think, oh, that's so simple, right? Conceptually, it's so simple to do recursion. And I forget this as well. This is really hard. But I have a couple like strategies I use. I don't know if this is like textbook stuff, but when I think about recursion, I think about a couple of things. So like this here, like going to the example, this is a really good thing to think about because it's very easy to think that factorial is like calling itself. And conceptually it kind of is, but it's really not calling itself. One way to look at recursion is that if I call factorial 5, I can actually pretend that that's like a new function that I just call factorial 5. It's kind of this looks a little bit like just a little trick, but you can think of writing a function called factorial 5 and you know it's going to call factorial 4, right? you know it's going to call some other function that's going to tell me how to do factorial 4. So if I just take that one case, how do I compute the factorial 5 if I know the factorial 4 already? So that's easy, right? So take another shot. If I know factorial 4, I have two different functions. I've given you factorial 4. Yeah, you just do 5 times factorial 4, right? So using that like little example, you can already bring yourself to at least kind of the shape of what the most important part of a recursive function is, which is the recursive step. So there's 2 pieces to every recursive function. You guys learned this, right? You have the recursive step and what else? The base case. Yeah, you always have the recursive step and the base case. So by thinking about like a single specific case here, rather than trying to think in general, we've already kind of given a hint at what the recursive step looks like. Yeah.
I'm guessing it's going to be return x times factorial x.
Yeah, all right. So the guy who was like not so sure about it now immediately knows, right? So just by doing an example, we've already given ourselves like a hint at what the recursive step is. So like I think when we see these general solutions, it's very tempting to think that's how you reach the solution. But for me, I could never do that. So I work on like little examples, and I just know that there's going to be a recursive step and a base case, and I work from there, and then I try to like work it out. So another important tip is to so now we know that there's going to be some kind of recursive step here. We know there's going to be something where it's going to be the value. So this kind of tells us that it's going to be the input value, and this tells us that it's going to be like the input value minus 1. So that's specifically for factorial. But when writing any of these recursive methods, the best tip I use, and actually for writing any program where you break it out into separate functions, is to just assume that the function that you're using is already written and already done, right? Like you do this with printf. Nobody's sitting down and writing. Printf was implemented by someone. It makes a system call, and you have to do some assembly code in order to make that system call happen. Nobody does that. You just say printf, I know what it does abstractly. I give it a string, and it's going to write that out to the console. So you can actually apply the same strategy for recursive functions. It's just a little mind-bending because you're still writing that function's actually not, the function's not done, but just pretend it's done. Pretend the function is done. So when I'm writing, this is why thinking about the function calls as different functions kind of helps a little bit. So when we write, so we know we're going to have a recursive step. So we got factorial, take some x. We know that there's going to be a recursive step somewhere. So this is our recursive step. And we know somewhere else there's going to be a base case. We know that already. That's what every recursive function is going to look like. There's going to be some recursive step or like multiple steps, and there's going to be a base case. All right. So when writing the recursive step, instead of thinking like, oh, I haven't written this function yet, how's it going to work when it calls itself? Instead, think of factorial, think of this function as already being written. Just like a convenient lie to yourself. Pretend like that function is already done and already works properly. You see what I'm saying? So just assume factorial is already done. So if we do that, then when we're writing our, so we can like call this this is our finished version of factorial. We just assume it's a different function. Somebody already wrote it for us. So if we want to write factorial, then we just write it assuming that somebody already gave factorial to us. So of course we could just say like return the factorial. So assuming somebody already gave us factorial, how would we then write factorial of x without the trivial case of just saying like return factorial? So how can we write this? Any takers? Anyone who is? So how about you? Give it another try. So for the recursive step, how do we just like write one step of the factorial function, assuming somebody's already given us this factorial function? So a little hint is that if we're looking at the function called factorial 5, if we want to compute that and we know factorial 4, we do 5 times the function we know already gives us the factorial of 4. What's that? I'm sorry, speak up.
I guess would it be that same chunk, just like -1 and then that.
Yes, to be more specific, so it wouldn't be this exact same chunk. So there's a -1 in there. So how does that look in the general case if you have x, factorial of x rather than factorial of 5? Where's x -1? For the, well, so can you write it out here? So I have my recursive step. I have my finished factorial function. You want somebody else to take it? So how about you? So x times the factorial of x -1. So this generalizes our example of the recursive step, because in our recursive step, for this specific case, the factorial of 5 took the number 5 and multiplied it by a function that already gave us the factorial of 4. So the way we generalize that is we say, well, let's assume we have a function factorial. So let me get rid of this extra text here. So assuming we have a function already written that we know will give us not factorial of 4, that we know will give us factorial of something, we generalize this by seeing the relationship between, factorial 5 and factorial 4. Well, it's x and x -1. So if we know that factorial is already written, we just guarantee that. We just assume it. We assume that factorial will work when we give it a value. So we give it factorial of x -1 because that sort of generalizes our specific case here. And then we just use that same pattern, x times factorial of x -1. Questions on this? Questions on this? You with me on this? So there's the result. There's the result for factorial of x, right? And so the interface for factorial, we didn't completely finish writing it, but the input of it is some integer x, and the output is another integer that is the factorial of that x. Yeah.
Basically, it's the above, but be the first thing in there, though.
Probably, yeah. That's probably what we do, but we're not there yet. So this is this return value just finishes the interface for factorial. So factorial takes a number and it returns the factorial of that number. I mean, that's what the function's supposed to do. So that's why we have, return value and return. So questions on this? Questions on the recursive step so far? Pretty makes sense, right? Okay. So every recursive function needs two parts. It needs the recursive step and the base case. So here's my recursive step. And what about the base case? So somebody was already starting to hit at it. When do we stop? Yeah.
I'm going to say that if x equals 1 or 0, return 1.
If x equals 1 or 0, return 1. Okay, so let's see. If x equals 1 or x equals 0, return 1. So this, yeah.
And just because I'm a paranoid nutcase, I would say if x is less than 0, return -1.
Okay, so that's a good specifying the input. I mean, yeah, we can definitely do that. You can say it's good to cover, make sure you have a complete function. You could also say this is unsigned int, or put a little specification, requires x greater than 0, for instance. There's other kind of formal ways to deal with this, but yeah, in general, that's right. Okay, does this make sense a little bit? Does this sort of make recursion a little less scary, I hope? Yeah. I'm sorry, say again?
I'm a little, I think you have to put x equals 1, if x is equal to 1, then it's going to run 1 times factorial of the next recursion, which is 0, which is also going to be 1. And you can multiply something by 1 as many times as 1.
Yeah. So what your classmate is pointing out is that if we make the base case, so there are more formal and proper ways to do an analysis of this function to prove that it terminates, and what's the computational complexity using all these different techniques, and you can guarantee at every step that x is monotonically decreasing. So you can do all that formal stuff. What your classmate is pointing out is that since we know that x is monotonically decreasing on every call, if we get to x equals 2, once we get to x equals 2, it will call factorial on factorial of 1. That will reach the base case and return 1. So there's a couple things here. One, it'll never reach this condition if it's a greater than, well, depending on how you define your input. And two, if we return 1, we do an extra multiplication. So my question to you is the program different if we do that? I mean, is it different or is it, huh? In terms of its output, that's a good point. So in terms of it's like what's observable about it, it's not different. For performance, it's different. If we make performance the observable, it is different. So I mean, the point here is that there's a distinction between functional equivalence, like how two pieces of code look depending just by looking at their inputs and outputs, and then expanding what you observe about that program. So for runtime, for instance, for doing performance engineering, even if it does the same thing, it's functionally equivalent. Performance engineering does matter. So it depends on how you look at it, whether they're different or not. Yeah. You could do that, but then we have the error checking problem as well. So I didn't want to go too much detail into this. I just wanted to show you how to like come up with a recursive function. But now you have it, you can actually start playing with it. So it's sort of good practice when you write these functions to fully specify the functions, or at least make it really clear what the inputs should be, so that the user of it won't make a mistake. But yeah, these are all good points. They are all equivalent depending on how you. They can be equivalent depending on how you see it. If you want performance and error checking to be part of your equivalence, then they're different versions. Somebody else have a question? Yeah.
So how does the performance affect from this code from the previous code? Like if statement is just an order-1 function.
Well, performance, like in computational, what do you call it? Computational complexity. Performance is like number of operations. For like search, it's the number of like comparison operations. So here it would just be like number of multiplications and arithmetic operations, and I guess like function calls.
But they won't be order-1.
It's not order 1. It's order. Well, so yeah. What is the computational complexity of this? That's a good question. Who says big O of 1? Who says big O of n? Well, it's recursive. Who says big O of n squared? Okay, yeah, big O of n. It's big O of n. So, because we're comparing number of multiplications, or however many constant operations we do each step of this. So I'm not going to get to complete recursion. Maybe hopefully this is enough. I guess one other thing to look at is somebody mentioned that this would be less performant than like a for loop version of this. So you can, any recursion you can always implement with iteration and vice versa. So is this worse or better performant than an iterate? Yeah, it's worse. Okay, who says worse? Who says better? Who says same? Who says it really depends on on what language you have, what system you're running on, how your compiler works. So in what size inputs you're expecting. So for like naive implementations of recursion will generally be slower because you're doing this function call. The recursion call itself, like at the hardware level, takes extra work. But actually, the C compiler and other compilers like this can do an optimization called tail call recursion. So if in the special case that you have a single recursive call and it's always the last one, the C compiler will just turn this into iteration for you. It sort of knows as a special case that certain recursion is like identical to a for loop or a while loop. And I can actually show, well, maybe next time. You can actually do this. You can actually compile, you can write this program in C, compile it to assembly, and look to see if it's doing recursion or not. Do you want to see that? Should we do that?
Yeah,
That'd be kind of cool. So we have 5 minutes. So let's see if I'm right. I could be wrong.
With your typing skills, I'm sure that's not a problem.
Well, let's try it. We have to actually write this function now. All right. Let me know if I make a mistake. Actually, let's just do it like this. Okay, so base case, let's do this. return 1, else, what is it? Well, let's do this. Return factorial x times factorial x minus 1. Is this right? Anything wrong?
The usual.
What? Did I miss something? Oh, okay, thumb up. Okay. And you know what? Let's make this unsigned in. Oh, no, that's okay. That's okay. Never mind. Okay, so let's compile this. First, let's compile it with no optimization, which is what happens when you do this. So dash capital S gives us the assembly file. And let's look for a function call. There's your call. So this is doing recursion because it's actually calling factorial. And let's see if, so I'm going to turn it all the way up to 11. And no call. There's no call here. So I just search for call. You can, let's see what this actually looks like. So yeah, it has, so you can see here, it's even just using the same register. It's not even bothering moving it back to memory. So it's literally just like jumping back to 2. You see this? So this is the loop right here. This is the loop. It's set up, it's set up the initial values. It's doing multiplication, subtract, over and over and over. No more function call. It's not only like remove the recursion, it's turned it into like, it's not even done register allocation. So it doesn't even bother storing it back to memory. It's pretty awesome, right?
Wow.
So this is a nice preview for the class next semester that I'm teaching called Program Analysis. It's a graduate course, but you might get an override. You can get an override. And I'll talk a little bit about program optimization at the end of the semester. So optimization is one of like the biggest fields in compilers. It's most of the work these days is on optimization, doing kind of magic stuff like this, like actually sort of kind of understanding what the program is doing and writing it out in a better way. You work with, machine language or LLVMIR. LLVMIR is like, has a huge optimization toolkit. That's why people use it, because you don't want to rewrite all this stuff yourself. And I think that was a good ending to see this actually happen. Thank God it worked. I wasn't lying. All right, so I'll see you next week.
Oh, well,